Okay, so first section we're going to look at this week is 9.1. Remember, next will be 9.2, but we're going to split that into two parts, and we're only going to do the first half of 9.2, and then that's it for chapter 9. Okay, the last section this week is 10.1. Okay. All right, so what we're going to look at in 9.1 is some graphing, a little bit of graphing on the calculator, using a different system of graphing that we haven't used before. Okay, it's called parametric. If you press mode, you've probably seen it next to the word function. Okay, it says parametric. So I'm going to talk a little bit about what that mode is and how you draw something in that mode. Okay, so we'll take a look at it. So the first mode is called function. Okay? And it's called function because you can only draw things that pass a certain test. Anyone remember the name of that test? If something is a function?
Yeah. The vertical line test.
Right. Anything you draw as a function has to pass the vertical line test, which means if you sketch something and you put in a vertical line, it only hits it one time. Well, if you draw in what's called parametric, we can draw different kinds of graphs that don't pass the vertical line test. If you put a vertical line in there, it hits it more than once. That's a little bit more complicated than we're going to look at, but that is a type of graph you can do. I think I have another one. That's like one we'll look at, similar. It's kind of like a sine wave, but it kind of repeats itself and goes back. The middle one, that one's pretty complicated. I don't know the equation for that off the top of my head. It looks kind of like a butterfly. It's just another kind of graph you can do. Okay, so these are all graphs that you can't do as functions. Okay, it's just you can't do them. Yeah.
I was just gonna ask if parametric also had like another definition for like.
Test.
Never mind. Oh.
So the idea with parametric is it basically allows you to draw things that you couldn't normally as a function. Okay, that's what it does. And let's just change it to parametric on the calculator so you can see what it looks like. Okay, so instead of putting it on function, you're going to put it on parametric. Degrees and radians doesn't matter for this right now. And then once you put it on parametric, you're going to press y equals. Okay, you're going to notice it looks a little bit different. For that blue graph, there's now two equations. Okay, so to graph something, you don't type in just one thing, type in two things. The idea of parametric is it breaks up how you graph something into two formulas. One formula is for the x values, and then another formula is for the y values. So it separates your formula into two formulas. That's what parametric is. Right, so let me write that down. So those two formulas that we're going to talk about, I'm just going to give them names here. I'll call one of them F, and I'll call the other one G. In our case, the first formula, the one I named F, is going to give you all your x values. The second formula that I named G is going to give you all your y values. And together, you put all the x and y values as coordinates, and then you get a picture. So the two formulas have to be given to you. So something like that. That's an example of a parametric system of equations. That's the formula for x. The bottom one is the formula for y. Okay, those will be given to you. When you take and graph something parametrically, it's called a curve. Even technically, if you draw it and it comes out as a straight line. Our book calls any picture that's drawn parametrically a parametric curve. And we're going to talk a little bit more about this interval. When you graph something parametrically, you have to tell the person what numbers you're allowing them to use in these two formulas. You say, for example, t can only be between 0 and 1. It's not that it couldn't be other numbers, they're just not allowing it to be other numbers for whatever reason. Okay, so there's always an interval that you have to say to the person when you're doing parametric graphs. Okay, those two equations, the one for x and the one for y, they are called parametric equations. That's the name of them, parametric equations. And t is what you're going to plug in numbers for to get points. So t is kind of like your variable. You'll notice on the graphing calculator, when you put it in parametric mode, normally when you press this button right here, what letter comes up? Normally an X comes up. When you press it in parametric mode, a T comes up. That's because in parametric, T is the letter that they use. It's like using X, but they don't use X. Okay, they use T. Yep.
Why do they choose T?
I don't know exactly why they choose T.
Wouldn't like P be more because it's the parameter?
Yeah, I mean technically you could use any letter, but yeah, the graphing calculators and most textbooks just happen to use T. I don't know the origin of why they picked the T. Or like why they pick X for the horizontal axis and Y for the vertical. Why not H and V, horizontal, vertical. I don't know why they picked those letters.
X and Y are cool. Is that like a capital I or T?
That's a capital I.
Okay.
Yep. Okay, so keep that in mind. That T is the variable that we're going to use. And another thing, since we're doing parametric, they don't call T a variable. It is the variable. They call it the parameter. Parameter, variable, it means the same thing in what we're doing. So when you draw something parametrically, one thing that's a little bit different about it is most of the time, it starts somewhere, it does something, and then it stops something. It has a start and a stop point. And the start and the stop point is controlled by information they give you in the problem. So does that mean every parametric curve starts and stops somewhere? No, there are some that go on forever. But a lot of the time, they don't. They start and they stop somewhere. And the way that you figure out where they start and where they stop is controlled by this. That's what they're going to give you in the problem. They're going to tell you the numbers that you are allowed to plug in for t. One of these numbers controls where the graph is going to start. Other number controls where the graph is going to stop. Okay? But you need to know those two numbers. So in general, let's just call those two numbers A and B. Again, they'll be real numbers when you do a problem. This controls where the curve is going to start. You take the first number, whatever number it is, and you plug it into the formula they give you. So for example, in that one, if you wanted to know where that graph is going to start, the number 0 controls where it starts. And to figure out the location, take the 0 and fill it in here and fill it in here. When you fill 0 into the top, that's going to give you the x value. When you fill 0 into the bottom, that's going to give you the y value. Put the x and y value together, that's the coordinate where the graph starts. to figure out where it stops. That's the second number. You take the second number, you fill it in for t. When you fill it in the top, you'll get the x value. When you fill it in the bottom, you get the y value. So B is where it stops. Well, B tells you the number to plug in to figure out where it stops. Okay, let's try that on this one. So 0 is the lowest value you can plug in for t. 1 is the highest value, and you can do everything in between. Since this is the lowest value for t, anyone have a guess what we call this number?
Origin.
You want to think of it in terms of like what the graphing calculator might call it. It's the lowest t value.
The minimum?
What the minimum for what? It's the minimum you can plug in for.
The X?
No, you're not filling in 0 for x. You're filling in 0 for t. So what do you think we call it?
T minimum?
T minimum. Yep. So this is called t minimum. It's the smallest value for t. And what do you think we call the 1?
T max.
T max. And part of graphing something is plugging in your T min and your T max. Okay, there is a spot for that now. That's new. We've never seen that before. Everything else is the same. The X min, the Y min, but you got to fill in that T min and T max. All right. So let's see if we can find where the graph is going to start. Okay, what number is going to control where it starts? 0. And we're going to fill that in for what letter? T. We're going to fill in 0 for T. So let's find what happens when we plug 0 into the X formula and then into the Y formula. Okay, let's fill in 0 for X. If you put 0 in right here, what's 1 minus 2 times 0? 1. Now plug in 0 for the Y formula. What's 2 minus 0? 2. That's where this graph is going to start. It's going to start at the point 1, 2. Now, what number is going to control where it stops? The 1, and we're going to fill in the 1 for T. Yep. So where the graph is going to end, plug in 1 for the X into the X formula, plug in 1 to the Y formula. Okay, so let's plug in the 1. What's 2 times 1?
2.
2. And then 1 minus 2? That's negative 1. Let's put that. Okay, so negative 1. And let's plug in 1. Okay, what's 2 minus 1? 1. So there's the coordinate where this graph is going to start and stop. All right, let's try graphing. Okay, so first thing we have to do is type in the two formulas. So if you go to y equals, if there's anything already in there, you can clear it. And everybody's should look like that if you put it in parametric. Now, what were the two formulas? So 1 minus 2t. Remember, just press the button you would normally press for x, and you'll get a t. And then y is 2 minus t. so that's all you have to type in on the graph screen. Now under window, what was my T-min?
0.
Okay, so I'm fine with that. What was my T-max? 1. Don't worry about T-step right now. Just for now, put it on 0.1. I'm going to explain what that is in a little bit. It's very important, but I'll tell you later. Now I need to set my window. What's the smallest x value that I have in these coordinates?
-1.
-1. So let's go to -2. We'll just go a little extra. What's the biggest x value? 2. So, no, the biggest x value is 1. So let's go 2. Okay, we'll go to the next. What's the smallest y value? 1, so let's go to 0. And the biggest y value? 2, so let's do 3. Okay, so you get a little extra on the screen. If you put everything in, just like we did here, and hit graph, you should get a picture that looks just like that. So basically that's a line segment. It has a start point and a stop point, and it's perfectly straight. Okay, any question on that?
How does that not pass the vertical line test?
No, it's not that every graph you draw parametrically has to fail the vertical line test. It's just that they can fail it.
Okay.
This particular one passes it. Yeah. So you can pretty much still do everything that you know how to do already and more with parametric. But you can still do everything we already know how to do.
It's supposed to be perfectly straight, right? I guess just a rendering issue.
Yeah, it's just because the pixels on the screen. It should be perfectly straight. Yeah. I could probably make it look a little bit straighter. Maybe if I did this, I don't know. Maybe. All right, so let's talk about what that T-step did. What did I have T-step on originally, 0.1? Okay. What was our T-min? 0. What was our T-max? 1. I want to count from 0 to 1, and I want to step in increments of 0.1. So what's the next one after 0?
0.1.
Like 0.1, yep.
0.2.
0.2.
0.3.
3.
0.4.
5.
6. 7. 8. 0.9.
And then 1. So what the T-step does is it controls how many points the calculator is going to use to make your picture. What the calculator is doing, but it's doing it very fast, is it's going to plug in 0 into each of these equations and put a dot. Then it's going to plug in 0.1 to each of these equations and put another dot. So essentially it's going to do something like this. And it's going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the calculator is basically graphing, whatever, 11 dots to make the picture, and then it's going to connect them all. That's what the T-step does. It controls how many points the calculator is going to plot. For a line segment, it's not as important. Where do you think having more dots would be important? Curve. Yeah. Because if you have a curve, like a circle, and you plot that many dots and then connect them all, it's going to look pretty good. But if you plot, say, 4 dots, it's going to look like a diamond when you draw it. Because the calculator is going to do 4 dots on the circle, and it's going to connect each dot with a straight line. It's not going to look like a circle. So there's a balance between how many points you need to make it look good, but you don't want to do so many points that it starts to slow the calculator down. Right? If we go by 0.01, you're going to notice it still draws it. It was a little bit slower, but it just counted from 0 to 1, going by hundreds. So that's 101 points, just like this was 11. Now, if I go 0.001, it's going to be 10 times slower. So what it's doing now is it's counting from 0 to 1 in increments of 1,000. So it's graphing 1,001 points to make that picture. And it still did it in about, 15 seconds maybe. So it's still doable. But that's way too much detail. You don't need 1,001 points to draw something perfectly straight. You really only need 2. Now, let's say you did something by mistake. Let's say you did that. So now it's trying to graph over 10,000 points. That's going to take a while. Okay. So we don't want to wait for that to finish because we put in too small of a number. Second, off. We'll stop. Okay. When the yellow circle isn't spinning in the upper right, you know you stopped it. If you don't stop it, you can't press any other buttons on the calculator. But now I can go back in and say, okay, I'm going to change my t-step. Go by 0.1, and there you go. There's your graph. Okay, so that's what t-step does. Controls the amount of points you see. It's like the amount of detail in the picture. It becomes very important when things start to curve. All right, let's try. Let's try this. So what I want to do is I want to take the problem we just had, and I want to change it from parametric back to the system we're used to. Okay? And you can do that most of the time. On this last problem, we can do it because it's pretty simple drawing. If the drawing starts to become too complex, you can't do this. It doesn't work. Basically, things that fail the vertical line test, this would not work nicely for. So eliminating the parameter means to get rid of the t and change it back to an equation like y equals mx plus b. In this case, it'll be y equals mx plus b because it's a straight line. Let's see if we can do that with our first example. And what I'm going to do to check that we did it right is, this is the graph that we just got parametrically. I'm going to do the same graph again once we eliminate the parameter. And if the pictures match up, then I know we did it correct. Okay, so I'm going to give you a hint at the first step. Bless you. Okay, the first step is to solve the x equation for t. Solve the x equation for t. Okay, if you were going to solve this equation for t, x equals 1 minus 2t, what do you think your first step would be? Yep, we want to get t by itself. So what would be the first thing you could move to the other side? You can get rid of the 1. And how would you move that over? So x minus 1 equals negative 2t. Okay. And what would you divide by? Negative 2. So we'll divide everything by negative 2. Negative 2 is gone. We end up with t by itself on the right. And what number is in front of x here, even though it's not written?
1.
Yeah. So what we really have is negative 1 over 2. That's the number that's in front of x. It's like a negative 1/2. So negative 1/2 x. And what's negative 1 divided by negative 2?
Positive half.
Positive 1/2. Yep. So it's negative 1 over 2x. And then I did negative 1 divided by negative 2, and I got positive 1/2. So now I have t by itself. what do you think I'm going to do with what's in this box?
Substitute it for t in the y equation.
Exactly. That's the last step. Substitute that for t in the y equation, and you'll have your answer. Substitute, how can I say it? Substitute answer from step 1 for the t in the y equation. So substitute the answer from step 1 for t in the y equation. So that's going to give me y equals 2 minus, and then what we had for t, we're going to fill that in. Remember, always put parentheses around something when you substitute. Negative 1/2 x plus 1/2. Okay, what do I have to do with this negative that's in front?
Distribute.
Yep, I got to distribute it. What's negative times negative 1/2 x?
Half x.
1/2 x. And what's negative times positive 1/2?
Negative 1/2.
Negative 1/2. Okay, and then my final answer I'm just going to put up because I have one more space. It's 1/2 x. What's 2 minus 1/2?
1.5.
1.5. Okay, so now we have a function. Let's graph that and see if it looks exactly like the other one. If it does, then we did it right. Okay, well, let's see. So to graph that, that's a function. What mode do I have to switch my calculator back to?
Function.
That's a function. I'm not using t anymore. I changed it back to what we're used to using with those two steps. So change it to function. Just so I don't have to use fractions, I'm going to do 0.5x plus 1.5. And I hit graph. Okay. Does that look exactly the same as what I had?
No, it's longer.
It's longer. Remember, when you draw something parametrically, usually the answer has a start and a stop point. When you draw something as a function, it goes on forever. So we basically have it. All we have to do is remember that the original curve was a segment. So we have to restrict the domain. And when you look at domain, what letter is the domain?
X.
That's the x. So we have to place a restriction on x. We have to tell the calculator, start at this value for x, stop at this value. Well, we already have the start and the stop figured out right here. Where does the x value start? 1. So that's going to be the biggest x. And where does the x value stop? -1. So we just have to tell the calculator, only draw between -1 and 1. Don't go beyond that, because that's our limit.
It already did it for me.
It already did it?
Yeah, I just flipped over to the y equals and then it was just already there.
Probably somebody already had it typed in.
I checked and it was all there.
Or
I could be wrong.
Yeah. Yeah, it won't do that for you. The only way to eliminate the parameter is to actually do it by hand. If it's already in there, yeah, it's just because somebody left it typed in. Okay, so what did I say for x? -1 to what? 1. Okay, so to put that in and tell the calculator to draw between -1 and 1, I insert parentheses around what I just typed in. So I press second and then insert. If you don't press insert parentheses, you're going to wipe out the first thing on the line. Okay, and the first thing is we want x to be greater than or equal to -1. So press x, press second, and then press math. Second math is how you get to greater than or equal to, or any inequality. and we want it to be greater than or equal to -1. Right? Let's just try that and see if it looks better. Okay, so what do you think? Is that closer to what we want? Okay, so we told it to start at -1, and where do we want it to stop? +1. So put that next to it in parentheses. Parenthesis, we want x to be less than or equal to 1. Second test, 6. I don't think you can do both in the same one, like a conjunction. I've tried that before and it didn't work. So you have to put each one separate. So this tells the calculator, draw this from here to there. Perfect. Now, does it look the same? Yep. Okay, so not only is this the answer, but you have to put this with it. That's part of the answer. Telling me where to start and stop for the x's. Yeah.
Could you bring the calculator back up for a second?
Mhm.
Is it drawing the rest of the line on the 0?
Yeah. There's nothing I can do about that.
Okay.
So yes, it is technically putting something there because the calculator wants to put something everywhere and it doesn't know what to do because I said don't put anything. So it just fills in a line right there.
Okay.
Technically, it should look like this. You shouldn't see that. But that's as good as we can do. All right, is there any question on it? Okay, so that's called eliminating the parameter. Eliminating the parameter. And those are the 2 steps to do it. You have to do it in that order, exactly like I have it written. It doesn't work if you do it any other way. All right, let's try this one. Okay, it says eliminate the parameter. So which equation are we supposed to solve for t? Yep, the x one. Can somebody tell me what you would get if you take the x equation and get the t by itself?
X plus 1.
Now, what do you do with that x plus 1?
Square it.
Well, how do you know to square it?
Substitute it for t.
Right. Substitute it for t right there. So you get y equals x plus 1 squared. And if they wanted that FOILed out, can somebody tell me what that would be if you multiply first outer, inner, last?
X squared
X squared.
Oh, sorry.
It's going to have 3 terms. X squared
plus 2x
plus 2x.
plus 1.
Perfect. What shape is that? Because the highest exponent is a 2.
Not a parabola.
It's a parabola. So this is what a parabola looks like when you write it parametrically, just like that. Now, the other thing we need to do is tell the calculator, we're not even going to use the calculator. We're just going to say where to start and stop. When you specify where to start and stop, you do it with the x's. The y's don't matter. That's the range. We don't usually define a range. We define the domain. Okay, what number here is going to tell me where my graph starts?
0.
0. And which formula controls what happens to the x values? The top one or the bottom one?
Top.
The top one. So let's plug, so we're not even going to use the bottom one. We can forget about that. We don't need it. Let's plug 0 in for t. If you plug 0 in for t in the x one, what do you get?
-1.
Okay, so that's where we're going to start. What number controls where we're going to stop?
Or 3.
3. So remember, 3 is not where you stop. It's the number that you plug in to find out where you stop. So now take 3 and fill it in. What's 3 minus 1? 2. So basically what this is going to look like is it's a section of a parabola. Might look something like that. It's not the whole parabola. It's just a section. And why did I use closed circles? Why didn't I use like open circles like that?
Because those points are included.
Those points are included because you have brackets. So you can have brackets or parentheses on your interval. A lot of times it's a bracket. All right, any question on that one? Okay. So I want you to keep in mind that it is not always possible to eliminate the parameter. There are problems that I can give you where you would be unable to do this first step. Wherever I wrote it. Well, the first step was solve the x equation for t. Definitely equations I can give you where you can't do that. But on the test, I would. Okay, you'll always have one that you can do. All right, so let's take a look at drawing a circle parametrically. So this is going to be where it starts to be important what we use for the t step. Because if we don't use a small enough number, it might look more like an octagon instead of a circle. We won't have enough points. All right, so let's think how we would describe one point on a circle. If we can describe just one spot, then we can describe any spot. Okay, let's describe the spot right there. I want to describe that point in terms of how far right and how far up I'm going. So what shape do you think I could draw here that would help me to see that?
Triangle.
Yep, I'm going to draw a triangle. Draw a line to the origin. Draw a line straight down. And this is how far over. What part of the coordinate do you think that green segment is going to be?
The x.
That's my x. And what part of the coordinate do you think the blue segment is? That's my y. And the thing that controls where this point is this thing right here. Right? From here to here. What is that thing? That's my angle. Now, normally we use a Greek letter to represent an angle. But what's the variable that we use when we do things parametrically? T. That angle is t. And depending on what you make that angle, you can control where you put that red dot. You want that red dot at the top? Make it 90. Okay, you want it right on the x-axis? Make it 0. And the hypotenuse of that triangle, it's the hypotenuse, but what would it be in the circle? It would be what? Anyone think they know what that? What is that hypotenuse in terms of the circle? Yeah, it's the radius. That's why we're going to call it r. So let's think how we could get a formula for x if they tell us the size of the circle and the angle. We're going to use a trig function. Let's start with x. What is side x relative to that angle? What position is it? It's adjacent. What position is side r? Hypotenuse. So what trig function involves adjacent and hypotenuse?
Cosine.
Cosine, yep. Cosine of my angle. Okay, what's adjacent again? X. And what's the hypotenuse? R. Now to type that in parametrically, we need the x alone. So what would x equal?
Cosine of t times r.
Cosine of t times r. We usually just write r cosine t. All right, so that's how you get your x. And how about y? What position is side y?
Opposite.
Opposite. So if I gave you the angle and the hypotenuse, what trig function would you use to find the opposite? You'd use the sine. So the sine of your angle would equal, what's opposite again? Y. Over hypotenuse is
R.
R. And same thing, to type it in parametrically, you need y by itself.
R sine of t times R sine of t.
R sine t. So that's what you type in parametrically if you want to draw a circle. Only thing you need to know is how big is your circle. That's R. So let's see if we can find a circle centered at the origin. That's what these formulas do. They automatically center the circle at the origin. If you want to move the circle somewhere else, we got to do something a little different. But we're just going to do it at the origin. And I want the radius to be 2. Okay. So anyone think they could tell me what the formula for x would be? Specifically if you let the radius be 2.
Two cosine t.
2 cosine t. And how about the formula for y?
2 sine t.
2 sine t. That will draw a circle that has a radius of 2, if you type everything in correctly. All right, let's type it in. All right, so let's go y equals, clear all that. Let's do 2 cosine t. Oh, what do I have to do first?
You have to be in parameter.
I have to be where?
So you have to be in parameter.
Yeah, parametric.
Or, yeah.
Yep. So let's go to parametric. 2 cosine t, 2 sine t. All right, I'm in radians. Let me just hit graph and see how it looks.
Not a circle.
That's not a circle. It's the start of a circle. We just have to fix what we're doing. First of all, if my circle is a radius of 2, what should I set my x min and max and y min and max to? Yeah, I would do all 3's and negative 3's. Okay, so let's take care of that first. So let's do negative 3 to 3. And let's do negative 3 to 3. Okay, so now we've got enough room to see the circle. Remember, it might not look like a circle because the screen is wider than it is tall. But you'll be able to tell that it goes 2 units in every direction by looking at the tick marks. Okay. We're using sine and cosine. In order to get a full circle, you have to go through a full cycle. When you're in radians, what number does the first cycle end at?
2 pi.
2 pi. What if we were doing degrees? 360. Okay, so for our t, which is the angle, let's start at 0, and let's go 1 full cycle. Okay, we would do 0 to 360 if we were doing it in degrees. Well, let's try it in radians. Okay. And did I get a circle that goes 2 units in every direction?
No.
No? Why not?
Well, it's overall.
Well, it's just because the screen. Yeah, if I did zoom 5, I could fix the distortion. But is it going 2 units in each direction? Just about. There's one tiny problem with this.
You said it.
Does anybody see the problem?
Doesn't connect.
It doesn't connect. Okay? And you can see that a little bit better if I take and turn my maybe if I make my axes off and hit graph. It's not quite connected. So let's think about why it's not connected. Okay, let me turn my axes back on. It has to do with the T step. Where are we ending for our T max?
2 pi.
2 pi, which is what number? Well, no, what's 2 pi?
360.
Well, not converting it to radians. What is 2 pi as a decimal?
6.
6.2.
6.28. Now, what is the T step?
0.1.
0.1. So let's practice counting from 0 to 6.28 going by 0.1s. So you have 0, 0.1, 0.2, 0.3, 1, 1.1, 1.2, 1.3. You get all the way to 6. You got 6. Let me do a step of 0.1. Can I do 6.1? Yes, that's still within my T max. Can I do 6.2? Yes. Can I do 6.3? No. So the last point that you see on this circle is from plugging in 6.2. We lost this 8318 because of the T step. So to make my T step a little bit finer, I could count by 0.01. What that's going to do now is it's going to allow me to get to like 6.2, 6.201, 6.202, 03, 04, all the way up to 6.2, 6.21, 22, 23, 24, 25, 26, 6.27, 6.28, but then I can't do 6.29. So I'm going to lose less of my circle. It's going to draw it 10 times slower because now it's plotting more points, but it will be so small now that I don't think you'll see the gap like you did there. And it can still draw it in under 30 seconds, so it's not terrible. Okay, so let's just compare it. Okay, does it look like there is a gap? That's not the picture I just drew. Well, just look at that one. Does it look like there's a gap in that one? No, it doesn't. You can actually compare it to the one that's right next to it. That one, the tick mark kind of hides the gap a little, but this one, it's much closer to connecting. Now, what if I did, let's just say pi divided by 2. No, I'm sorry. Leave that at 2 pi. Change the one below it. Pi divided by 2. What's pi divided by 2? In degrees.
90.
That's 90. So let's count by 90s. You get 0, 90. What would be the next one? 180, 270, 360. That's it. You're going to get 5 points where the first one and the last one are on the same spot. So what would you get if you do 5 points and the first one and last one are on the same spot?
A diamond.
Yep, you're going to get a diamond. That's not what it's supposed to look like. If you want to draw a diamond, great. But that's when we're drawing a circle. Okay? Now, instead of pi divided by 4, let's do pi divided by 8. That's now every 45. That's going to give you 9 points. So what would this shape look like? If you have 9 points and the first one and the last one are the same. That's going to be an octagon. Closer to a circle. And I don't know if you can tell if it's an octagon, but it's not doing it. The sides are a little bit more jagged, right? You get a little bit more. So if you, actually I think I meant pi divided by 4. That's what I meant. Now you can tell it's an optic paper. All right. So if you don't do enough points, it just starts to look more blocky. Any question on it? So what would happen if, let's just put the t-step back at 0.1. I know there's going to be a little gap. That's okay. What happens if I stop at pi instead of 2 pi? Yeah, I'm only going to get a half circle because I didn't go a full cycle. Right? So if you want to draw a half circle, go half a cycle. If you want a full circle, you've got to go a full cycle. What would happen if I did 4 pi? 2 pi brings me around once.
Extra thick circle.
Yeah, because of the decimal and the rounding, you're going to see it go around a second time, and the points might be slightly off from the first time. Yep, they are, I can tell. They shouldn't be, but it's just because of rounding. So what happened that time is it went around twice. Okay. And that's why it got a little thick because of rounding. Any question on that? Generally, we only go around as many times as we need to do it one time. So in that last problem, the domain and range of the circle was -2 to 2 and -2 to 2. We did -3 to 3 to have a little extra. But what was the domain we used for the parameter to make sure we got a full circle? 0 to 2 pi. Yep. So it's important to understand there's a difference between the domain for the parameter and the domain and range of the screen. Okay. Big difference. Okay. So the last thing we'll do is we're just going to try graphing a few more parametric equations and see what they look like. So example 5 says, find the graph of, and it gives us this for x, and that for y. Where I just put the 2 red boxes, do those kind of look like anything that we just did? What do those 2 equations kind of look like? They look kind of like the equations for a circle, but there's a very big difference. What's the difference? We have a T instead of a what? An R. If these 2 numbers were R's, we would get a circle. What does this number in front? What was it when we did a circle? It was R, and that stood for what? It stood for the radius. So it was a fixed radius. This is a variable radius. It's a radius that's constantly changing. That's not a circle. Anybody have an idea what shape you get if the radius grows bigger and bigger, the more you go around your shape?
Spiral.
You get a spiral. Yep. So a spiral is basically a circle with a radius that's just getting bigger all the time. All right, so let's try typing it in. So make it t cosine t and t sine t. Very small change from a circle, very big difference in the picture. Okay, let's go to our window. Actually, I think I already have 4 pi in for t max because I was playing with that in the last problem. So put in 4 pi, but I already had it. And let's hit graph and just see what it looks like. Okay, well, it's going off the screen. So let's see what the biggest part of the spiral is, so we don't go off the screen. What's the biggest t could ever be?
4 pi.
That's given. The biggest t can be is 4 pi. Now, think about the graph of sine. When you graph sine, what's the highest that sine ever goes?
1.
And what's the highest cosine ever goes? 1. So the biggest number you can get here is a 1. The biggest number you can get here is a 4 pi. Multiply them together. What's 4 pi times 1? 4 pi. That is the biggest that the spiral can ever get. Okay? Is 4 pi units from the origin. So let's set everything to 4 pi. Let's do negative 4 pi to 4 pi. And negative 4 pi to 4 pi. How many revolutions of the spiral do you think I'm going to see? 2. Every 2 pi is 1 revolution. Now, I did a little bit of overkill by setting everything to negative 4 pi to 4 pi. Okay, the only place that you really needed the biggest part of the window was over here, the x max. The y min is close, but it didn't need 4 pi. The x min definitely didn't need it, and the y max definitely didn't. Okay, so when you're graphing a whole revolution, the x max is where the longest part of the spiral ends up, way over there. If you stop at a full revolution. So that's a spiral. Any question before we look at the last graph? All right. Let's look at last week. Okay, so it says find the complete graph, and it says x equals 5 sine t, and y equals 5t cosine t. All right, this is nothing like we've done before. Let's just type them in and see what happens. Okay, so we got 5 sine t and 5t cosine t. And it says, what's my t min in this case? Yeah, that's fine. What's my t max? Okay, 20.5. So I'm just going to hit graph and see what it looks like. Okay, well, not really seeing a great picture of what's going on here. Let's make sure I typed everything in right. 5 sine t, yeah, everything looks good. Okay. Let's start with the x. That one's a little simpler. I'm going to break that down into looking at this and then this. What's the biggest that sine can ever be? 1. And what's the biggest that the number 5 can be? It's a constant. It's a 5. What's 1 times 5? That is the biggest that you need to go on the x-axis, 5. It'll never get bigger than that. Okay. What's the smallest that sine can be? Or I want to say, let me say it this way. What's the most negative that sine can be? Negative 1. And times 5. Negative 5. So that handles your x-axis. You don't have to go beyond negative 5 to 5. Everything is going to be there. Yep.
Why is it not cosine for x and then sine for y?
Just a different graph. Yeah, so this isn't a circle or a spiral. Nothing like that at all. All right, let's think about this one. Cosine. What's the biggest cosine can get? 1. What's the biggest t can get? 20.5. And what's the biggest 5 can get? 5. Multiply those together, and that's the biggest y value you could ever see in this whole graph. So what's essentially 5 times 20.5? 102.5. Let's just call it 103. And now same idea again. What's the most negative that cosine could get? Negative 1. And if you multiply all that together, what's the lowest value you could ever get? Well, yeah, let's just call it negative 103. Let's graph it now and see what we got. So setting the window is going to make a huge difference in looking at this graph. It's a lot easier to see what's going on now. So it looks kind of like a watermelon or a beach ball. I don't know. It looks,
It's like a lawnmower thing.
yeah. And if you set Tmax higher, you're just going to get more and more bands. It would always be between -5 and 5, but it would keep expanding up and down. More stripes. Okay, so graphing things parametrically, it just takes a little getting used to it.
Like that intrinsic data, everything will come.
Let me, I need to fix that.
You were involved. What's my name? You're the one who asked for this.
Is there more questions?
Wait, so what is the right?
Any questions? Okay, so that was
Okay, so that's the homework. 1 through 11 odd, and then 21, 22, 25, 29, and 30.